Okay, this is Chemistry 111, lab number 4, molar mass determination by freezing point depression. We'll determine the molar mass of an unknown substance, basically identify it, by measuring the freezing point depression of the solution. So we'll measure the freezing point of water. I'm guessing it'll be about 0 degrees Celsius. We'll add a known amount of an unknown salt. See how much the freezing point goes down, typically, who knows, 5 degrees or so. Use that data to figure out what it is we added. Ions in a solution will always lower the freezing point of the solution. They interfere with the freezing, that means the crystallizing process. The formula looks like this. The change in the freezing temperature is equal to the freezing point constant, which is always just a number for water. That is 1.8 degrees Celsius per molal, so that's 1.86, times the molality, that's a measure of the concentration of that solution, times the Van Hoff factor. Let's just call that the ion count. And in this case, it's always going to be 2. For substances similar to, like, say, sodium chloride, 1 cation, 1 anion. Just so you know, there's lots of substances which have a ion count much higher than 2. For example, aluminum oxide has an ion count of 5. It breaks into 2 aluminum cations and 3 oxide anions. What I suggest you do is rewrite this equation so it solves for exactly the only unknown that's in this equation, which is the moles of solute. In other words, check this out. The change in the freezing temperature, well, you're going to measure that. Say it's 5 degrees. K sub F, that's 1.86 degrees Celsius per molal. Known. Known. The moles of solute is unknown. On the other hand, the kilograms of solvent is known. After all, you weighed out how much water you used. The ion count is 2. So solve exactly for that, and you'll have everything else be known, and you should be able to solve for this. I won't do that for you. I expect you to do that. That doesn't give you the molecular weight of your substance, but it does give you how many moles you had. Molecular weight is equal to grams per mole, and you do know how many grams you add. After all, you weighed out that salt to put it in there. So take that. Once you have the moles of solute, take the grams that you weighed out, divide it by the moles, and you'll have the molar mass. It should match one of the unknowns. Okay, here's the procedure. First, we'll make a nice ice salt bath. After all, we cannot freeze water just by putting ice around it. We need to go below 0. Salt will do that. That, in fact, is a colligative property. Determine the freezing point of water. In other words, let that stuff cool down and freeze. Use log or pro. I won't bore you with all the instructions. And take 2 trials to measure the freezing point of water. I'm guessing you'll get about 0 degrees Celsius. Now make a solution of your unknown salt as described in the manual. You'll know how many grams of salt you used. You'll know how many grams of water you used. You'll need the grams of salt right there. You'll need the amount of water you used right there. You'll figure out the freezing point of the solution. Do it 3 times. Take the average. And you should be able to figure out what that unknown salt was. It's an interesting experiment in that respect. A few notes. Some students are surprised to hear that the freezing point is identical to the melting point in terms of the temperature. They happen at the same thing. It's just going from either a solid to a liquid or a liquid to a solid. You'll be generating some graphs, but don't worry about printing them. We don't have to. The danger for this experiment largely is that you don't know what your unknown salt is, so assume it's toxic. The solutions will get quite cold. When you make your salt ice bath, make sure you have a good slush for it so that it works effectively. Don't prepare your solution 3 times. That would be unnecessary work and would produce some error in terms of concentration. Simply melt it after each time it freezes and reuse it. The freezing point is actually when you measure it on a graph, not just equal to the lowest point on the curve, because at that point it hasn't frozen yet. Things usually supercool a little, and then the temperature goes up. This may be due to the fact that freezing is a energy releasing process. But the bottom line is that you want to measure this bottom line. This bottom line, as it's flat, does give you a nice indication of the freezing point of the solution. So that's what you want to get for your freezing point. Do not forget to write down your unknown number, and when you do your calculations, what we're looking for is 6 of them. The average freezing point, I'd like to see a calculation for that. That's the average of 2 trials. The freezing point depression, that's where I see you rearrange your formula and simply solve for, no. The freezing point depression is the change in the freezing temperature averaged over how many trials? Looks like 3. The solution molality is the moles of solute divided by the solution of molality. There it is. That's the big thing that requires you to punch in everything except this number here. So rearrange and solve for the solution molality. Get me the molar mass. Remember, once you have the moles of solute and you have the grams of solvent, you should be able to calculate it. Note that you have to use grams per mole to get molar mass. And then, since you've done 3 trials, get the average molar mass. I'd like to see all 6 of those calculations, please. And that is Chemistry 111, lab number 4.